Hi, good evening, everyone. Good evening. I hope you guys are doing good. And I must be audible, visible. The screen should be clear. Good evening. Join me as we start another exciting discussion on probability, which is, of course, a function of permutation combination. And yeah, we will see some of the questions which appear at the test level with respect to probability. Join me in and let me know if I'm clearly audible to you. It's all good to go. Am I audible? Let me know on this front quickly so that we can get started. Yep. Well, guys, good evening. I'm hoping that I'm clearly audible. It sounds like sound control seems to be fine at my end. So here I start. Okay, let me quickly introduce myself. I'm Belvi Srinivas. I've been working in this industry since 2007. That's about 14 years now. So in that 14 years, I contributed in various capacities, both in terms of management as well as in terms of training. Yeah, so when it comes to the training, I especially trained the students in the areas of QA, DI, LR with respect to also a little bit of counseling side, guiding the students to reach the right kind of scores and get into the right kind of B schools. That's a little bit about me. Yes, so as you see that I have developed skills to train the students effectively, especially in the area of QA, DI, and LR in the previous time. Yeah, and if you'd like to join and want to have quick interactions with me, you can always log on to this particular Telegram channel, and on this channel you can drop short texts and brief discussions we can have on this particular channel. Good evening, guys. Good evening, Devanshu. Good evening, Nazia. Glad to have you guys here. Glad to have you guys here. Yeah, so before I start, let me quickly do quick announcements and then we will get on to the lecture. Announcements, yes. So as you all are aware, Unacademy offers two kinds of subscription plans. One is Plus, the other one is Iconic. So in the Plus subscription plan, you get exposure to structured courses at various different levels, and also for various entrance exams. There would be separate channels, so batches running for OMETs. It can be for IIFT, it can be for ZAT, it can be for TISNET, and similarly different courses running for CAT at various different difficulty levels and various kind of courses, exclusive courses on algebra, exclusive courses on LRDI, so on and so forth. That's what you mean by structured courses. And along with that, you also get access to the study material and the test, weekly test, all that stuff. So Iconic gives you the interface to interact with the mentor of your choice. In the 1:1 capacity, you can set up the meetings and you can have interactions. That is what Iconic, that's the additional benefit of Iconic, in which you can set up the meetings to discuss your doubts. You can set up the meetings to discuss your plan of action. That is how you want to plan your prep, or how you want to strategize your exam, or it could be with respect to some of your interview questions or application form related issues, all of that. So that's what Iconic technically does. And these are some of the exciting upcoming batches. And if you're looking at IIFT specific, so that's on 16th October, that's about a couple of days back it started. I'm also a part of that particular batch. I'm teaching algebra out there. Yes, on 20th onwards, there are a few other batches starting for OMETs, CAT, and other management tests, and you can take a look at some of these exciting courses offered. Yes, so Unacademy believes this is one of the good platform, good plans to buy because about 5 months to go till you are finished your interviews, etc. This is one of the subscription plans, preferred subscription plans. There is an offer if you're looking at short courses, short duration plans because you want to have a quick look at the exams and some of the related courses with respect to those exams that you're taking up. By 3 months pack you get 1 month free, or if you're looking at cat 22 12 months pack you get about 3 months free, things like that. But this is a very short period offer is valid only till about next days. That's on the offer side. Yes, iconic subscription appears to be comes with a little bit of premium side. So premium being that simple reason being you get a handful of one-to-one interactions till you get into a B school of your choice. That's a little bit about the announcements for now. So at this stage, let me quickly take a stock of how many of you are in here and who are all joined in. It would be great if you can quickly let me know who are in the meeting. So let me know who are all in the meeting out here. Okay, Devanshu, Nazia, Rishabh. Oh, great. All right. All right. Good guys. Hmm. Good. Good to have you guys out here. Superb. Superb. Yeah. Rishabh is here. All right. Yeah. Cool. All right. So let's get started on this note. Let's get started on this note. So I have, so as usual, we are doing on the job kind of training in the sense I will not go to the basics of what is probability, right? So I don't speak at that, speak at that particular basic level. What we do is let's assume that we kind of know kind of basics on it, and we will try and work with the questions built around it. Of course, while doing the questions, I will give relevant basics around it. Wherever it is required to deal with certain basic elements of it, we will deal it. Probably we will do it in two parts, maybe some part today and some part some other day. We'll do a couple of theorems in the next part, so we'll go a little deeper in the next part, different things. So today also we'll try and take a look at some of the questions which appeared in CAT and various other exams. Basically, we don't have time for various other exams that IIFT is at. Even they do throw some good questions on these particular topics. But yes, so for our study purpose, we will take up questions from CAT and try and work around them. So meanwhile, before we do some CAT questions, I will give some background. So that background would certainly help you to warm up a little bit. Okay, all set? Are you all sitting with book and pen? No passive viewing? Can I assume that yes, you are all sitting with a book, pen, you're in the right position? It is not that you are kind of lying on the bed or lying on the sofa. Yep. Are you all set to go? All good? Yeah, before I start, let me ask you one more question. How many of you have taken the mock yesterday? How many of you have taken the mock? So there is one free mock by Unacademy as well yesterday. So whichever mock that you have taken, have you written the mock? Yes, no. So if you have written the mock, just quickly put the text. How many of you have taken the mock between you? Devanshu, Rishav, Nazia, Srishti. How many of you have taken the mock? That doesn't matter. How many of you have taken the mock on Sunday? Yes, there was Sunday, right? Sunday you must take a mock. Hey, I'm here regularly now with you guys. Devanshu has taken a mock. Srishti has taken a mock. All right. Rishav has taken a mock. Who else? Nazia, you took a mock? Yes, no? Okay, one year you took on Saturday itself. Very good. Very good. But try it on Sunday. I hope Sunday, yesterday you had some other thing, some other important things to do. Otherwise, do it on Sunday. Get it to the Sunday because we write most of our exams on Sunday. Therefore, put that in the autopilot mode. That's what I meant. Doesn't matter unless on some of the Sundays, if you are badly held up, that's okay to write on Saturday. Instead of missing, it's okay to do. But keep Sunday 2 hours, 3 hours of time, right? Keep those 2 to 3 hours kind of, right? So because you need a little bit of warm up before the test, all that stuff. Good, very good, very good. All right, good. Most of you are writing. That's very encouraging, guys. That's super. Okay, here we go. Let's do a little bit of warm up. So technically, you know that hey, when it comes to probability, three things we can never ignore is what? Coins. The other one is dice. The other one is cards, right? Yeah, cards. So these are the three things we don't ignore. But that doesn't mean that the questions come from these three areas. Absolutely not. But these are the three things which we kind of don't ignore. We keep these three things for sure, and then we will try and operate. I mean, that's from the school perspective. Right, from the exam perspective, yeah, everything is equally important. It is not that coins, dice, and cards are very important, not areas. Absolutely nothing like that. But yes, when we start discussing anything on the probability, we understand that this is what we do, guys. When you get into the statistics, etc. So I mean, statistics is definitely already one of the subjects that you do in the management. So when we say statistics these days, naturally you learn a little bit of Python, all that stuff. They will teach a little bit of programming as well, because data is the key, and we can't handle the data which has 30,000, 40,000, 1 lakh rows of data, right? That's what the kind of data as a manager you kind of get exposed to. There will be lakhs of lines. So therefore, how do you deal with those lakhs of lines of data, or thousands, at least 20, 30,000 lines will be there for sure when you get exposed to the data. That's a kind of data. What you do in the DI, 10 rows, some 4 columns, that's not the data that you look at. That's very small. So when we get into the B school and you start already doing the statistics, etc., you do some 30,000, 40,000 or lakh lines. That's what the kind of data you kind of get, kind of those many rows, maybe about 10, 15 columns. That's the kind of data you kind of get exposed to. Naturally, how do you work with the Excels therefore? So how do you ask right questions on the data? So and then probability becomes a part of that. All probability study becomes a pretty much part of it. That's where already they kind of ask that your permutation probability is a little bit in place or not. Otherwise, when we go there, you might start facing the challenge, because nobody teaches probability in the B school, right? They don't teach. They only apply probability in the B school. Calculus is also required. Nobody teaches calculus there. They will directly apply calculus. That's it, right? They won't teach us what is calculus, all that stuff. Yeah. Okay. Nevertheless, any which ways, so that background you will figure it out later. Coming back to this. So therefore, I'm just starting in a very traditional manner, saying that a coins. So I'm just starting with the coins so that we warm up and get into the cat level questions in the next 40 minutes or so. So here we go. 6 coins are tossed together. Find the probability of getting at least 5 heads. Say, what is this? Probability of getting 5 heads or probability of getting all 6 heads. This is what we are kind of looking at. First question, 6 coins are tossed. Find the probability of getting at least 5 heads. We all know probability is to do with the event. Hey, there is an event. There is an event, probability of the event. What is the probability of the event? Things in favor of the event. Things in favor of the event divided by total outcomes. Outcomes in favor of the event. Technically, you write this as, this is a framework, right? You first identify the event, then you write outcomes. Out means outcomes in favor of the event. Outcomes in favor of the event divided by total outcomes. Divided by total outcomes, which we all know. I don't have to say this, but since solid now, before we get into this, as a matter of fact, I'm telling you this is what it is, right? Yeah. So just a warm-up question. So at least 5 heads, what does it mean? At least 5 heads. I'm fine getting 5 heads, or I'm fine getting 6 heads. Or means plus. What's the probability of getting 5 heads? 5 heads is 6C5. You will write this as 6C5. You may wonder that, hey, why 6C5? Because you have 6 coins. Any 5 coins giving heads are fine for me. Divided by what? 2 raised to power 6. Hey, why 2 raised to power 6? Coin 1 gives me 2 outcomes. So we already did this in one of the permutation combination classes. I said that I tossed 3 coins, total outcomes. 3 identical coins, how many outcomes? 2 dice, how many outcomes? 2 identical dice, how many outcomes? So again, I don't have to repeat this. We did that during that particular drill, and you'd be pretty comfortable with it. So coin 1, 2 outcomes, coin 2, 2 outcomes, coin 6, also 2 outcomes. And then you say that your denominator is 2 raised to power 6. Hey, all 6 heads, probability of getting 6 heads, 6C6, everything has to give me that. But what is the denominator? Denominator is 2 raised to power 6. 6C5 is nothing but 6 plus 1, 7. Therefore, you say that your answer is nothing but 7 divided by 2 power 6, which is 7 divided by 64. Guys, very first question. Anybody outfoxed here? Anybody is having a trouble here? Anybody is having a trouble with this? What I'm trying to do here? Let me know any trouble here. Anybody has any trouble in understanding this? Just in case. Things can't get easier than this. Right? Just on the lighter note, right? If anybody is getting a trouble at this point in time, you have to sign out. Right? If you think that, hey man, this itself is a trouble, then you have to sign out. Right? Because I don't think things can't get anything easier than this. Okay? Any which ways. Right. Let's go to the next one. At least 1 head. Yeah, I want to talk about this. Whenever you get this at least one is a pretty standard phrase, right? At least one is a very, very standard phrase when it comes to probability, especially probability in permutations, counting, in any counting business. At least five is not a standard phrase. This is not a standard one, but at least one is always a standard one. The way to approach, why I'm calling it as a standard one is at least one is always way to approach is total probability. This is a total probability minus probability of none. That is the way to approach at least one. Whenever at least one comes, we generally approach it by saying total probability minus probability of none. That is the way to approach. At least one is a pretty standard phrase which we use in day-to-day use of probability study, especially statistics. Once you start with the data, when you start asking question on the data, that is when you come across these kind of premises, right? Otherwise, you will not come day-to-day analytics. Those are in the field of analytics. You come across you ask these kind of questions on a very day-to-day regular basis. Fair enough. All right, let's come to this. What is total probability, by the way? 1. So that's where I'm introducing this word. Total probability is 1 minus probability of none. None means what? No heads. All right, he said at least one head. That is probability of getting no heads. Probability of getting no heads. You say that, hey, therefore this is nothing but 6C0 divided by 2 raised to power 6. Simple answer. Therefore, you say that answer is 63 divided by 64. All right, so that's just inclusion of the standard phrase. At least one is a pretty standard phrase in the counting, and the way to approach it is always total probability minus 1. Total probability is 100%, which is nothing but 1. All right, yeah. On this note, let's go a little deeper into this. Okay, here comes one of the CAT question. Whenever I put a star here, I slightly modify that CAT question for learning perspective. What I do from the learning perspective is sometimes I dilute it a little bit, sometimes I just make it a little bit, bring a little bit of twist so that the learning becomes better. That's all I do. Whenever I do that, I put a star, right? Otherwise, with small change, with 5% change, it becomes actual CAT question. Good, great, good guys. All right, go ahead, answer this question now. I just give a orientation, you answer now, then I will come back and we'll start discussion after a minute or so. A minute time. All of you start now. Pull out your copies, book and pen and start working. I gave the background. I warmed you up. Use that warm up and start working on the questions. A minute of time for you guys to think. Go ahead. Yeah. All right. Okay. Yeah. Yeah, Anushka, ask what you want to ask. Okay. Good. Very good. Right. Okay. Let's take a look here. All right. Meanwhile, Anushka, you can ask what you want to ask there. So let's take a look at this question. A coin is tossed 6 times. What is the probability of getting heads in exactly 4 consecutive tosses? In exactly 4 consecutive tosses. Watch it, guys. Watch it. Let's take a look at this. Okay. There is a first time the person has tossed, recorded the reading, second time, third time, fourth time, fifth time and sixth time. Let's say that, okay, he got how many times he wants head? Exactly 4 consecutive. Okay, first one is head, the second one is head, the third one is head, fourth one is head. Okay, 4 consecutive has come. I need to break the sequence. I broke the sequence with tail, and then the other one is also tail. This input is fine. Also, in addition to this, there is nothing wrong with this input as well. If the first 4 are heads, the focus is on the first 4. Sure, the first 4 are heads, and then I break this particular sequence with a tail. I break this particular sequence with a tail, and then I introduce a head. Now this statement has not gone wrong. What is the probability of getting heads in exactly 4 consecutive tosses? Yeah, this is exactly 4 consecutive tosses, and then the sequence has broken, and then I got a head. There is absolutely nothing wrong with this particular statement. Did you get this? My second case. Case 2 is clear to all of you. Did you understood this second case? Is this case clear? Is this case clear? Case 2 is clear. Case 1 definitely you would have thought about. Is case 2 clear? Is case 2 clear? Case 2 is also 4 consecutive heads. You have to break the sequence using this tail. After that, you can either include a head or a tail. Sequence is broken. So this is where some people make a mistake. This is the case in which people kind of make a mistake. Right, good, yeah, so fine, because first case, solid case 1, we all kind of think case 2 is the catch in this particular cat question. Case 2 is the catch. Fair enough. After that comes, okay, hey, the middle 2, middle 3, middle 4 have given the heads, therefore the either ends or the tails. That is one case. Then you may say that the final case here would be, hey, last 4 are the heads, and therefore there is a tail. Alright, I am breaking the sequence. Before this, there could be either a head or a tail. So therefore you say that there are 5. There are going to be how many cases? There is a first case, there is a second case, there is a third case, and there are 2 cases. I'm just 2 cases I've squeezed between this. So similarly, I can squeeze this case also like that. In a similar fashion, I can say this can be head or tail. Because once the sequence is broken here, I am free to have either heads or tails here. Once the sequence is broken here, I am free to have a heads or tails in the beginning. Therefore, 5 out of 64 is going to be the answer. Comfortable, everybody? Did it make sense? Everyone clear about this choice? Quickly confirm. Let's move forward. Then you would have thought about it. Just warm up. Initial mistakes do happen. All right, just the mind has to warm up a little bit. While it is warming up, we tend to make these kind of silly mistakes, small errors. Christy, all heads can be B. What all heads can be B? I didn't get this. All heads can be B means what? 5 cases. I'm showing, no, there are 2 cases here, 1 and 2, 2 cases here. This is my third case. So where there are 4 consecutive heads. This is my 4th and 5th case. 4th and 5th case. I didn't get your chart. I didn't get that. If there are all heads, no tails. All heads, no tails is only one case, no? All heads and no tails would be only one case. Right? That would be only one case. Okay? Fine. Let's go to the next one. Let's go to the next one. Okay, here is the one. Cat question as it is. Take a minute, guys. Pick it up. It's all counting. Push yourself. Yeah, Devanshu. Okay, coming back to that. There is the word exactly 4. The what? Why you are not continuing it here? 4 consecutive. Read till here, no? Devanshu, why you are reading in parts? You are saying that I am reading only till here. Exactly 4 heads. Heads in exactly 4 what? Consecutive. Something can happen before that, something can happen after that. That's okay. But did I get 4 consecutive or not? Read completely, no? He didn't say that exactly 4 heads should be there, right? Exactly 4 heads is different from exactly 4 heads in consecutive positions. These are 2 different phrases, right? Devanshu, is this clear? Exactly 4 heads is different from getting exactly 4 heads in consecutive positions. That doesn't mean that the 5th head should not be there. But if the 5th head is in a consecutive position, then there is a problem. Yeah, if the 5th one is in a consecutive position, in a problem. Break the sequence. All right, now just like here. All right, now I have 4 consecutive heads. Break it, and then you are free to have another head if you want. Right? Yeah. But 4 consecutive stands for this. That's it. He didn't say that in the entire, in the entire experiment, 6 experiments you did. In the entire 6 experiment, there should be 4 heads. That is different. That is different. Okay, yeah, that is different. Okay, good. Fine, let's go to the next one. Take a minute, friends. Take a minute. Reflection time. We have done just 2 questions. Yeah, we need to go a little faster. Otherwise, learning gets hampered. Go ahead. Okay, Nazia. All right. Yeah. Put additional efforts and learn. Right? Okay, all right. So what has happened? In this bag, there are 2 types of coins. Very good, very good. Some of you have given the right answer, right? There are 2 types of coins. Now, first one, there are 2 fake coins. These are fake coins. So what does the fake coins has? It has head on both the sides. That is head and head. They're supposed to have a head and tail, but both sides it is printed as head. There are 2 fake coins. Okay, what about the 14? The 14 are appropriate. These are no problem. These 14 coins are appropriate. That is head on one side and a tail on the other side. Tail on the other side. Therefore, here, what is probability of getting the head here? Because author is interested in that probability of getting the head on any of these coins. Probability of the getting head is 1, certain. This is called as a certain event. Event is what? Getting the head. Probability of the getting the head on the fake coins is 100%. That is the fake. That's a 1. What is the probability of getting the head on the any of these remaining 14 coins? It is 50%, because one side there is a head, one side there is a tail, right? This is what happens there. So this is the certain event. We call them as the certain event, 100%. This is the certain event, right? The other one is not a certain event. Other one has a choice of 50%. Okay. Now the question is, therefore, probability of getting the head when one coin is picked out of this point is from which side you are picking. Are you picking from the fake ones, or are you picking from the appropriate ones? That is the question. If you pick from the fake ones, if you pick one coin from the fake ones, then probability of getting the head is 1. First, select the coin and write its probability. I'm writing numerator. Numerator means favorable conditions. I'm writing for the favorable conditions. Pick one coin. What if I had picked one coin out of the 2 fake coins? Okay, 2C1 choices. Choices of picking is 2C1. And then what is the probability of getting head out of this? 1. Or. Alright, or what can happen? I will pick one appropriate coin out of 14, or I will pick one appropriate coin out of 14. Hey, what is the probability? What is the probability of getting a head out there? The probability of getting a head out there is half. Pick the coin and then find the probability of getting the head once you selected that particular coin, right? So which coin you are picking and tossing, that makes the difference. Which coin did you pick before you toss? Now, what is the total number of ways of picking the coin? 16C1. Because when you pick a coin in random, you have picked any of these 16 coins. That is what could have kind of happened out there. Therefore, what is the answer? 2 plus this is nothing but 14 into half, which is nothing but 7 divided by 16, which is 9 divided by 16. So what has happened here? To confuse us, he just divided, he made one of the probability for one of the coins, he made it as a certain event. See, we learned these definitions. What is the point I'm trying to make in the first few minutes of the lecture? We learn the definition of certain event, but nobody is going to ask us the certain event. This is the question asked in the CAT which talks about certain event. Okay, you learned something about the certain event. I'll give a question, figure out that's a certain event there. So that is what they mean there. Okay, so because we learn these definitions, sometimes we think that okay, knowing the definition is good enough. No, it is not about the definition. We need to recognize as a part of the problem that hey, it is, yeah, this is the certain event here the probability is going to be 1, things like that. Okay, yeah, everybody is good with this question? Everybody is good? Any doubt? Anyone? Understood? Understood? Sample spaces are clear to you? Everyone is clear on this? Any doubt, anyone? Quick. If there is a doubt, let me know what is the kind of doubt you have. Who is this mysterious fragrance? Nice way you have put it. Name is a very nice way, but I'm not able to recognize. Yeah. Yeah, you said that you joined a little late. Good. Nice. Take a look at this question, guys. Think about it for a minute. Don't worry. I will give the relevant background behind each of these questions. What do we mean by those questions? All that we'll speak about. Don't worry about it. Yeah. Take a minute and try to think about these very simple CAT questions. Yeah. Oh, that's a nice name. Oh, your name is Fragrance. Awesome. Okay. All right, guys, listen, let me give you this particular question. Why don't you answer this? So let me give a question here. So this is again CAT question on permutation side, right? CAT question on a permutation side. Listen, all of you listen here. All of you listen here. In a three-digit number, everybody listen, very important. Yeah, in a three-digit number, how many three-digit numbers can be formed? How many three-digit numbers can be formed such that the digit in the hundreds place is greater than the digit in the tens place, which in turn is greater than the digit in the units place. What is the answer, by the way? How many three-digit numbers can be formed? Forget the probability question. Let's first make a quick study. Let's understand, then we will come back to that. Because if you didn't answer this in 1 minute, nobody answered, which means there is some problem. Yeah, how many three-digit numbers can be formed such that the digit in the hundreds place is greater than the digit in the tens place, which in turn is greater than the digit in the units place? Simple. So there has to be three distinct digits, no doubt about it. Let's say that I ask Devanshu, give me some three digits, and Devanshu says that okay, I will give you the three digits. My three digits are 1, 2 and 3. Okay, if you give me these three digits as the sample size, then I will say that you have to write 3 here, you have to write 2 here, and you have to write 1 here. There is no choice in the matter, right? Okay, so which means on this sample size, I can make only one arrangement. Okay, then I asked Rishav. Rishav said that, okay, sir, all right, I will give the digits as 1, 0, 1 and 2. Rishav gave me this particular sample size. Then I'll say that, okay, Rishav, then you can form only one number. You must write 2 here, you must write 1 here, you must write 0 here. So this is the number, which means on this sample size also you can write 1. Therefore you say that now I can ask somebody else. Okay, I can ask Nazia, you give a sample size, she will give sample size, I will write 1. One year gives some sample size, Fragrance gives some sample size, it's all 1. So therefore you understood. Now you may say that how confidently you say 1. Simple. All right, now so I take a case of 0, and one case I should take a non-zero case. Simply, very simply put, one non-zero case and one 0 case. You should always, when you are trying on the sample size, you should take one 0 case and you should take one non-zeros case, and you should check the frequency. So what is the frequency? Which means how many numbers I am able to form on a non-zero case. Sometimes it could be different from the number of numbers you can form on a 0 case, but you checked it. Hey, here also frequency is 1, here also frequency is 1. Therefore you say that, man, I have 10 digits, 0, 1, 2, 3, like this up to 9. I have 10 digits. I just have to select 3 digits. For every selection I can form only one number. This is going to be my answer. Are you all comfortable with this? That's the answer. That's it. Selection first and arrangement of the selected ones. How do we learn the permutation? Selections first. This is selections. First you select, selections first, and then arrangement of the selected ones based on the condition. This is the very basic way of dealing with the arrangements. Comfortable? Everybody comfortable with this 10C3? Yes or no? That's the answer to this question. 10C3, everybody clear on this? We can simplify that. That's no big deal. Simplification is no big deal. But did you get that part clear? How to deal with this zero case and non-zero case, how to deal with that. Is that clear? That's important. The way to deal with approach. Clear? Everybody clear on this? Guys, everybody stay tuned and quickly respond. Right? If you stay tuned and respond, it will be better. Good, very good. Okay, let me twist this now. Let me twist this. You answer this. Then we'll go to that cat question. Now let me twist this. Hey, digit in the hundreds place is greater than the digit in the tens place, and the digit in the tens place is less than the digit in the units place. Now you tell me the answer, my friends. You tell me the answers. Answer. Answer to this question. How many 3-digit numbers can be formed such that the digit in the hundreds place is greater than the digit in the tens place, and the digit in the tens place is less than the digit in the units place? How many 3-digit numbers can be formed? How many 3-digit numbers can be formed with this condition? I'm not timing. I'm waiting. I'm waiting for some of you to respond. Yeah, I'm waiting. Think clearly. Okay. Okay. Yeah, good. All right. So I give sufficient time to think. Fine. If I give a little more time, well, you will keep thinking. So any which ways. Now let me come to this. Okay. So somebody give me this sample size, right? Somebody give me this sample size, right? Say the Ramya has, Vanya has given this sample size 1, 2, 3. So I will write the smallest number here because this should be the smallest, no doubt about it. This should be the smallest because hundreds place, tens place is less than hundreds place, tens place is less than units place also. Therefore, the smallest of the numbers I will plug it here. Between 2 and 3, I have a choice. I can write 2 here, 3 here, or I can write 3 here and 2 here by continuing this one. 1 continues here, but then between the remaining 2 digits, I can write 2 on one side, or I can write 3 on the other side. Okay, what if it is a zero case? What if there is a zero case? No problem. Smallest digit sits here, 0 sits here. I have a choice. Either I can write 1 here, 2 here, or I can write 2 here, 1 here. 0 continues to remain there. Fair enough. Therefore, for every sample size, I can create 2 numbers. Okay, therefore, what is the sample size? You say that, okay, for this 10C3, my sample out of 10 digits, I can pick any 3 digits and I can form 2 numbers. And I can form 2 numbers out of every selection. For example, for this selection, I could form 2 numbers. For this selection, I could form 2 numbers. Like this, how many selections? 10C3 selections. For every selection, I can form 2 numbers. Okay, that is one side of the story. Second thing is, okay, I never said that the digits has to be distinct. I never said that, right? Now be careful. I said, tell me the number of 3-digit numbers so that this condition is fine. Now the point is, what is wrong with this number? What is wrong with this number? Isn't it accommodating the condition? Of course, it's accommodating the condition. I can write 101. There is absolutely no problem. 101 is also fine, which means what? I can satisfy this condition with only 2 digits. I can satisfy this only 2 digits. For example, I asked Vanya. Vanya said that, okay, I will give only 0 and 1. Fine. I will put 0 here and I will repeat the 1. The larger of the 2 digits, I am going to repeat this, right? Then I asked Nazia. She said that, okay, sir, take 8 and 9. No problem. I will write 8 here and I will repeat the 9, which means what you are trying to say now, hey, another way, second part is, hey, I can deal with this particular condition with 2 distinct digits. Just with 2 distinct digits I can deal. Okay, which implies 10C2, I select 2 digits. The smaller of them I will write at the in between, and the larger of the 2 I'll repeat it. Fair enough. So which means one number can be formed for every selection when you consider only 2 distinct digits. To form the 3 numbers, you consider only 2 distinct digits. That is also fine. Therefore, you say your answer is 10C2 into 1 plus 10C3 into 2. You got to think completely. Don't add words. Just because I said 3-digit number, hundreds place, don't add words saying that the digits has to be distinct. Don't add words while you are trying to interpret the question. Guys, everyone clear on this? Everybody clear on this? These were the cat questions. These are the cat questions, something like this. Cats at IIFT, they keep asking some simple questions like this. Pretty simple one. But people fail to think at times. They think one side of it, forget the other side of it. Yeah. Yes, Nazia, it need not be distinct. You just have to work with the condition. That's it. It should be a 3-digit number. 3-digit number such that the digit in the hundreds place has to be greater than tens place, which in turn has to be less than the units place. So this is fine, right? 989 accommodates that condition. Yeah, 989 accommodates that condition. Clear? Clear? If you want to do a drill, do this. Beautiful. Now you guys do this drill. If it is clear to you, do this particular drill. What is the answer to this question now? What is the answer to this question? It's just a 3-digit number. That's it. I just have a 3-digit number with this condition. 3-digit number with this condition. There's a condition. How many, say, if you have to word this, listen to me, if it has to be worded, it would be worded like this. How many 3-digit numbers can be formed such that the digit in the hundreds place is less than the digit in the tens place, and the digit in the tens place is greater than the digit in the units place? They will write that beautiful sentence. So finally it becomes this condition, right? That sentence, when you arrange, it becomes this. What is the answer? What is the answer? Guys, what's happening? Are you guys very tired today? I was feeling little tired, right? I was feeling little tired around 9:30 in the night, right? I was seriously contemplating of canceling the class, right? I was feeling very, very tired today around 9:30, yes. And then again, I had a cup of coffee and then I felt better, right? Something like that. You guys also feel little tired getting into the class? I generally don't, but I was feeling very tired because Bangalore weather is very bad today. At Bangalore, the weather is since morning. I mean, not only since morning, it's for the 1 week, it's been raining, and weather is very, very dull. And I had a very hectic day as well since morning. I was feeling little tired. So some of you feel tired like me, drink some coffee or tea, some hot water, and then sit. Otherwise, you will make these kind of mistakes. You'll simply make these kind of mistakes. Simply saying same. It is not same, it is different. Right? It is different. Let's take a look at this one. Okay, first let's start with 3 distinct digits. Let's start with 3 distinct digits. Okay, so let's say who is there? Avyav. Avyav was very quick to respond. Avyav, will you please type the meaning of your name? Yeah. Just curious. That's it. So when I come across some new names, I generally ask you guys. Yeah. Oh, it's raining everywhere in India, is it? Okay, good. But not as bad as Kerala, I guess. Okay, so here we come. So all right, listen to me. So let's say that, okay, somebody has picked up a non-zero case, 3 distinct digits. They decided that, sir, I will go with 3 distinct digits. Fair enough. 3 distinct digits. You started with 1, 2, 3. The largest digit has to sit here. That's a meaning. Tens place is greater than hundreds place. Tens place is greater than units place. Means what? The best of the digits has to sit here. Done. Taken. 3 is sitting here. 1 here and 2 here. Or 2 here and 1 here. The best digit is sitting here. Okay. Then I said that, oh Nazia, you give me your case. And she said that, okay sir, take this. 0, 1, 2 is my case. Fantastic. 0, 1, 2 is your case. The best digit sits here. Therefore 2 sits here. If 2 sits here, now Nazia can form only one number. 0, 1 and 0. Now she can't say that, sir, 2 will continue to be here. I will write 0 this side, 1 this side. No, nothing doing. If she gives me a 0 case, only one number can be formed. If it is a non-zero case, 2 numbers can be formed. Firstly, give the understanding that, is this clear now? Is this clear now? 0 case and non-zero case makes a difference. Don't take it for granted. You have to try it and then take it. Is this clear first of all? Is this clear first of all? Is this clear first of all? Frequency is different. Non-zero case 2 numbers, 0 case only 1 number. Is that clear? Oh, okay, Vanya. All right. Good. You pushed yourself. That's fine. I think you pushed yourself too hard. Yeah. If you're feeling tired, go ahead, relax. You can listen to the recorded one. Guys, others clear. Fragrance is clear. Rishav is clear. Devanshu is clear. Nazia is clear. Okay. Clear, right? What I'm trying to say. Avyav Agarwal, are you clear what I'm talking? Yeah. Okay. Fine. Good. Yeah, when you're clear. Good. All right. So now how do I bifurcate this? Therefore, you say that, hey, non-zero case, listen to this very carefully. If it is a non-zero case, in the sense you have the sample sizes, listen guys, now this is the trick here. While writing, you need to be very, very careful. 0 to 9. The first case, when I'm writing the non-zero case, ignore 0. You will select 9C3 because all at 1, 2, 3 means what? I'm selecting a non-zero case. If you are selecting a non-zero case, then you can select the non-zero digits in 9C3 ways and you arrange them in two ways. 9C3 ways of selection. Each selection can be arranged in two ways. Alright, each selection can be arranged in two ways. Now coming to the zero case. Coming to the zero case means what? You are trying to say that I want a 0. If you want a 0, 0 is already selected. That is one way. Now you want another two non-zero digits because you still want 3 digits. You want another two non-zero digits out of the remaining 9 digits that can be selected in 9C2 ways into 1. This is what you mean by these two cases. This case now added to this case. This gives me the result of having three distinct digits. Are these two numbers clear to you? 9C3 into 2 and then 9C2 into 1. Is this clear? What is this one for? This one is for 0. I want a 0. Then I want two non-zero digits. This is for non-zero digits. And one arrangement possible. Clear about this? This side is clear. This side of the story is clear. Having three distinct terms is clear because the frequencies were changing. 2 is a frequency for one case and 1 is the frequency for the other case. Therefore, the story looks like this now. This is how the story looks. Rishabh, is this clear? I'll come to that. Is the story of what I'm doing here. I'm started by saying that three distinct digits. I've started by saying that case 1, 3 distinct digits. I will form this condition with respect to 3 distinct digits. Is this clear? Is this clear? 3 distinct cases is clear. Then there is another side of the story, right? I can form this with 2 distinct digits also. Why do I need 3 distinct digits? I can do this by using 2 distinct digits. Right? Okay. 2 distinct digits. For example, okay, Rishabh said that I will take 1 and 2. Okay, if you take 1 and 2, you write 2 here and you repeat the 1 here. Simple. That's it. Okay, then all right now. So one other person said that I will take 0 and 1. If you take 0 and 1, you will write 1 here and 0 here. That doesn't matter. In the sense you are trying to say that 0 cannot be considered. Only one case. When you decided to consider only 2 distinct digits to accommodate a 3-digit number, you can have all it. You should have only non-zero case. Only non-zero cases are permitted. Non-zero cases are permitted means 9C2. Why 9C2? 0, 1, 2, 3, 4 up to 9. 0 is ruled out because when you take 2 distinct digits out of 3, or when you take 2 distinct digits, 0 does not work because once it's here, then the 0 gets repeated and hence that is already ruled out. 0 ruled out. Out of the 9 distinct digits, I need 2 distinct digits and hence you say that on this side 9C2. I will take 2 distinct digits and I can form only one number. Why? The best of the 2 digits remains at the center. The smaller of the 2 would go on to repeat on either side. 9C2 into 1. So answer is 3 parts. This is one part here. This is the second part here and 3 part here. You got to add all these 3 parts to get the correct answer. Comfortable? Made sense? Made sense for everyone? Did it make sense? 3 parts. This question gets divided into 3 parts. Your thinking gets divided into 4 parts every time. Hey, what are the 4 parts? This is the first part. Alright, this is the first part, part 1. Your thinking always gets divided into 4 parts without doubt. This is the first part here. This is the second part here. What is the 2 parts? 3 distinct digits. Then part 1, part 2. What is part 1, part 2? Considering having a 0 in the sample size and having a no 0 in the sample size. Again, you come to the two distinct digits. Then you will say that there is a part 3 and part 4. Then you find out the answers based on each one of those parts and you will add those up. Is this clear, my friends? Is the pattern clear to you? Which means the framework is clear. The frame has to be clear. The framework has to be clear. Otherwise, the counting goes wrong. If the framework is clear, rest everything is fine. It is only a matter of time getting the numbers. Clear? Is this clear? I'm not receiving any responses from you. Are you guys there? Yeah. Good. Now why don't you answer this probability question then? Come back now, you answer this. I gave 15 to 20 minutes of background for this question. That is too much. Answer this with that background. Try to answer this. We made a sufficient study. Next time you should not falter. Now answer this simple question based on this background. I gave 100% extra background for this question. What's happening, guys? Are you guys tired? Not able to respond? Why only one person responded? I gave almost 1.5 minutes here. Okay, what is the sample size? Just like 0, 1, 2, 3, you have 1, 2, 3, 4, 5, 6. There is no 0 here. There is no 0. There is no problem. All I have is 1, 2, 3, 4, 5, 6. That's it, because it's a dice. A dice is rolled 3 times. All I know, it rolled first time. Then it is the second time, then it is the third time. What is that author is trying to say? What he did in the first one should be better than, right, in the second roll when compared with the first, and greater in the third when compared with the second. This is how I want. Simple answer is 6C3. That is the answer. Over. That is the numerator. What is the denominator? 6 cube. That's a denominator. Numerator is 6C3. What is 6C3? Select any 3 numbers. Said that, okay, sir, I get 1, 2, 3. If you get 1, 2, 3, you better write 1 here, you better write 2 here, and 3 here. There is no choice in the matter. There is only one way to arrange every single set. So there are 6 numbers. Dice has 6 numbers. You want 3 distinct numbers because it's the ascending order. So he's saying that the result should be in the ascending order. So I need 3 distinct digits, without which ascending order is not possible. So you put them in the ascending order. Only one ascending order is possible for 3 numbers that you get. So 6C3 is your numerator. Denominator is 6 cube, because when dice is rolled 3 times, what is the total? What is the total number of outcomes? 6 into 6 into 6, which becomes your answer here. Simplify this, you will get your number from there. That is 6C3 is 20. 20 divided by 6 into 6 into 6, right? Yeah, so therefore this becomes 3 and 3, and this becomes 5, right, into 6. This is the required answer, which becomes 5 divided by 54. Are you all with me? Clear about this? Are you all with me? It is the same concept. There is no threat of 0 also here. It is much simpler than what I did. That's what I said. I gave 100% extra input for this question because they were also CAT questions. Since I was doing probability, I picked from probability perspective. But these were also, some of these were also CAT questions. I gave many more questions based on that. That's it. Comfortable? Everybody comfortable on this thought? Clear? Clear? Yeah. Think about this. Beautiful question. It's not a dice, it's a cube. There are no numbers 1, 2, 3, 4, 5, 6 here. It's a cube. This is one of the beautiful questions from CAT. Yeah, just think about it for a minute. I'm not expecting you to answer. You guys would be tired as well at this hour. Think, it's one of the beautiful questions. The concept behind this is beautiful. You should know that concept. That's important. Yeah, listen carefully, guys. This might all it. Now, don't miss out on what I'm trying to say. Otherwise, it will take you for a ride. Okay, listen very, very carefully. There are two dice. Listen to me. There are two dice. Dice one configuration is given. Dice 2 configuration is not all it. Dice, it's cube 1 and cube 2. Let me write it as cube 1 and there is a cube 2. Cube 1 configuration is given. Cube 2 configuration is not given. What is on cube 1? There are blue and red faces. One face is painted blue. The first has one blue face and 5 red faces. Okay, configuration is given. What about the second one? Blue and red, not given. The answer is given. What is the answer? Probability of getting the same color is 7 by 18. Answer is given. He is asking the configuration, that is how many faces are blue and how many faces are red. Listen carefully. Let us say that X faces are blue or X faces are red. Let's say that X faces are red and Y faces are blue. Y faces are blue. What is X plus Y? 6. Here, what is this X plus Y? X plus Y is 6. What is this 6, man? This 6 is nothing but 6 faces. You can't say that X plus Y has become 10. X plus Y has become 10 means what? How? All it is, cube has only 6 faces. Where you are getting this 10? So I am saying that X plus Y. You may say that no sir, I will write this as 6 and I will write this directly as 6 minus X. I am fine. I am absolutely fine with this thought. If X faces have red, remaining faces would have a blue. So, okay, now you may wonder why I wrote X for red only, because that's what I'm interested. How many faces are red? So whatever the number of faces are red, I would rather make my first assumption there. Therefore, I made my first assumption there. Okay, let me go with the thought that X faces are painted red, remaining 6 minus X faces are painted blue. Give me understanding that so far you understood. This X and 6 minus X are clear. Give me that understanding. That is half of the problem. Thinking till there is the half of the problem. Give me the quick understanding that yes, it made sense so far. Is this clear? X and 6 minus X are clear to all of you. X faces are red. I don't know what is X. I have to find that out. X faces are painted red. Therefore, remaining 6 minus X faces are painted blue. Other than Devanshu, others are also understanding what I'm trying to say. Right? Others are also understanding. Very good. Yeah, now listen. Now listen, guys. Everybody listen. So, both should be red or both should be blue. Very good. Very good. Now look at the question. Now let's come to the question. What is the question? When tossed simultaneously, what happened? Probability that both have the same color has become 7 by 18. What do you mean by that? Probability of two blues, probability of blue and blue, or probability of red and red. What do you mean by red and red? First cube also showed up the red, second cube also shows up the red, both are showing the red, is equal to 7 by 18. That is what the meaning of this number 7 by 18. Blue, first cube has shown the blue, second one also has shown the blue, first one has shown the red, second one also has shown the red. It becomes this. Okay, I'm sure all of you know how to write this. The first one, what is the probability of the first one showing the blue? There is only one blue here, therefore you say that 1 out of 6. 1 out of 6. Hey, what is the probability of the second cube showing the blue? Probability of second cube showing the blue is 6 minus X by 6. Hey, what is the 6 minus X? Because I don't know the number. The number is 6 minus X according to me, blue. 6 minus X faces are painted blue. Therefore, 6 minus X out of 6 faces on the second cube. Okay, plus. Coming to the next one. Hey, red. All right, we are writing it for red. How many faces are painted on the first cube? 5 of them. So I'm writing the result for this. 5 out of 6. Into how many faces on the second cube are painted red? X of them. Therefore, you are saying that X divided by 6. What is this outcome? This outcome is 7 divided by 18. This entire outcome is nothing but 7 by 18. You are saying that okay, therefore 6 minus X plus 5X. 6 minus X plus 5 times of X divided by 36 is equal to 7 divided by 18. 18 one time, 18 two time, and hence you are saying that 6 plus 4X is also equal to 14. Therefore, 4X is equal to 4X is equal to 8, and hence X is equal to 2. Therefore, X is equal to 2. Okay, guys, did it make sense to you? Everybody is clear about this? Everyone is clear about this? Everyone is clear? All good? All good? Is this clear to everyone? Did you understood what we did? This is the CAT question. Yeah, we should be able to think. They are very simple CAT questions. It is not as complicated as I'm trying to explain sometimes. Explanation takes time. But once you understand, It is not pretty complicated as such. We just have to be able to think and put those numbers in perspective. I mean, we need to practice at the right level. That's my point. All right, then we'll be able to handle them. So we just have to build our skill set at the kind of right level. Okay. All right, let's take a look at this question. I will take up next few questions. The next lecture, I will take up few other questions. I'm skipping some of them so that because that will take a lot of time. If I gone into the previous question, it will take 15-20 minutes because I have to give a background. Right? Some questions have huge background, some questions less background. Take a look at this particular question. Try to make some sense out of this in the 1 minute's time. Take a minute and try to make some sense. Dead heat means draw. Just in case you don't know what is dead heat means draw or a type. Draw or a type, whichever way that you remember. Listen. Okay, good. Very good. Yeah, listen. Everybody listen. Let's do that. That's a reflection time. Don't worry. If I give a little more time, we all will be able to close it. That's no big deal. Think about this. The probability of A not losing. Listen to this carefully. Probability of A not losing. Two things, which means what? Win for A or it is a draw. Either A winning or drawing. That is what you mean by not losing. Why? Three things can happen. When A is playing, three things can happen. A can win. Think from A's perspective. Either this fellow can win or he can make a potential draw or this fellow can lose. When I said not winning, what I meant, not winning, not losing. By using the phrase not losing, what did I mean? Either winning or a draw. That is what I mean by not losing. Okay. Therefore, winning for A and drawing, this probability is 4/5. So there is a probability. I can write like this: probability of this and probability of D. If you want to complete the thought, it should technically look like this. Okay, that is 4/5. What about B? All right, B is 5/8. What? Not losing. B not losing means what? Probability of B winning or probability of a draw. Probability of a draw between A and B. All right, that is becoming 5/8. This is what he's saying. Okay, now what do I do with this? All right, first let's understand. In a given match scenario, what can happen? In a given match, either A wins or B wins or there is a potential draw. These are the three possibilities. Now these three probabilities together is 1. Of course, there is a P, guys. All right, if you want to complete this thought, please write P here. Probability of A winning or probability of B winning or probability of a draw. Together is what? 1. That's it. That's a total probability in a match. Total probability is 100%. So which is nothing but 1. This is what is 1. Add up these two equations. Let me add up left hand side and let me add up right hand side. What do I get? Probability of A winning, probability of B winning, plus 2 times the probability of a draw. That is 2 times probability of a draw plus probability of a draw. I am not doing anything. I am just adding all the 4 terms there. Adding, which has become what? 4/5 plus 5/8. I added the left hand side. I added the right hand side. But what is the meaning of this much? All right, that is the A winning, B winning or a draw. So which means this particular bracket is nothing but 1. This is nothing but 1. 1 plus probability of a draw is equal to 4/5 plus 5/8. This is what you are trying to say there, right? So which is nothing but 32 plus 25/40. 32 plus 20, 32 plus 20, 25, all right, which is nothing but 57, right? 57 divided by 40, that is 1 plus probability of a draw. So therefore, what is probability of a draw? We got simple by evaluating. Probability of draw is nothing but 17 divided by 40. Do you all get this, what I'm trying to say? Is this clear to you how to think on these patterns? They will make us think. Simple probability question, they will make us think in CAT. All they do is they will kind of make us think a little bit. And once we are clear with our concepts, what is the total probability is 1. So because we learn that concept that total probability is 1. But the point is they'll be interested, how do you use it? Knowing total probability is 1 is good. But how do I use it is what they kind of check. right? How do we make use of it is what is important to them, right? Good, very good. All right. Are you all learning something? Is it becoming deeper, dull, boring? I don't know how the probability you are feeling it because I'm not doing from the scratch or something, but is it making sense? Are you able to connect? I'm asking you guys, are you able to connect, make a connect with what we are discussing? Yeah. Okay. Great. Good. All right. Nice. Super. As long as you are learning. Very, very good. Yeah. Here is another cat question. Nice. Okay. So here is another cat question as it is. Try this 1 minute. You think about this. Whether you answer or not is a different issue. These are not difficult ones either. After solving, you are realizing that these are not difficult ones. You just have to learn to deal with these things. You have to build the skill to this level. That's it. Yeah. Think about this. Think about this situation. Okay. I will extend the time by another minute because it might strike. Okay. This is what is happening here. Push yourself. Think a little bit. Avayo, explain the question. Is there a problem in understanding the question? I will come to it. I'll come to it. Let others think. If we keep talking, others can't think. Okay, guys, I will come to the question later. I'll come to this question later. First, you answer this question. You answer this question. Everybody answer this question. I have four vowels P, Q, R, S. I have four consonants P, Q, R, S. Listen to this very carefully, and I expect that everybody answers this question. Everybody answers this question. I have four consonants P, Q, R, S, and I have three vowels A, E, I. I have three vowels A, E, I. Okay, I have three vowels A, E, I. Okay, yeah. So now my question is, how many 7-letter words can be formed? Listen carefully. I have four consonants P, Q, R, S, and I have three vowels A, E, I. How many 7-letter words can be formed such that vowels are together? How many 7-letter words can be formed such that all three vowels are together? Please put this in the chat. Put the answer. Whichever form you want to put, you put the answer. There are four consonants, three vowels. My question is, how many 7-letter words can be formed by using all these fellows such that vowels are together? All vowels are together. Such that all, guys, did you understand my question? All vowels are together, I said. Go ahead, Rishav, Avyav, Fragrance, put your answers. What is that away you are trying to put the answer? Are you kidding? These many words, only 5 words you can form? Okay, yeah. All right. You submitted before you are writing full. All right, got it. Yeah. Good, very good, very good, very good. Which means concept was known. No big deal about this. Concept was known about this particular question. Yeah, cool. That's right. What you did is right. You just bind them together. So therefore you say that, hey, P is an independent entity, Q is independent, R is independent, S is independent, and this whole thing put together is one particular entity. Therefore you say that, hey, externally on the face of it, I can move these 5 things. So therefore it is 5 factorial arrangement. But these 3 fellows can arrange among themselves. They can move among themselves in 3 factorial ways. Bang on, your answers are right. Your answers are right. This is correct. All right, now these 3 fellows, without going out, wherever they are, they can rearrange themselves in 3 factorial ways. Very good. Now let me ask you this particular question. Look, there are 2 married couples. There are 2 married couples, A dash and B dash. B dash. In how many ways they can be seated such that the couple sit together? How many ways you can make them sit? You have 4 chairs, linear fashion. These are 2 married couples. How many ways they can be seated such that couples sit together? Husband and wife sit together. Go ahead, answer. Answer this. How many ways they can be seated, therefore the couples sit together? So that couples sit together. That's right, Srishti. That is the right way. That's the right way. Yeah, that's right. That's right. Okay, so therefore you are saying that, okay, I will bind them. Couples has to sit together. Therefore, I will say that instead of having like this here in the earlier question, listen, everybody listen. In the earlier question, you said that vowel should be together. I am saying that, okay, this, what if I would have said in the earlier question, consonants also should be together. They would have made it like this. Likewise, I am doing it here. Hey, this couple should be together. This couple should be together. You can move around yourself. You can move here. You want to exchange the positions, you please exchange. But then you should be together. And then you say that, hey, there are 2 external groups. There are 2 external groups which can be arranged in 2 factorial ways. Couple A and A dash can arrange themselves in 2 factorial ways. B dash can arrange themselves in 2 factorial ways. Right? Therefore, you say that 2 factorial into 2 factorial into 2 factorial. That is the answer. There are 8 ways they can arrange, the 8 ways they can sit. Right? There are 8 ways that they can sit. Is this 2 factorial, 2 factorial, 2 factorial clear, everyone? Is this clear? Is this clear? How do you make 2 couples sit so that husband and wife are together? There are 8 ways to make them sit. Is this clear, everybody? Is this clear? External arrangement are 2 ways. External arrangement are 2 ways. Then the husband A dash can arrange among themselves in 2 factorial ways. B dash can arrange among themselves in 2 factorial ways. Is this clear? Asim, is this clear what I'm talking? Nazia, is this clear what I'm talking? Avyav, clear? Okay, good. Now come back to this question. That's a background to this question. Good, Vibha. Very good. Yeah. So now let's come back to this question. What is the background? That's a background here. 10 notes means what? See, this is the CAT question as it is. They wrote notes. They expect that we'll be able to understand, right? They expect that we'll be able to understand. As simple as that. Sometimes I print the CAT question as it is because they think that we are smart enough to understand what author has written, right? That's important there because we will be reading what professor is writing on the board. We will be reading what your other group of students are writing when you are sitting in the when you are sitting in a presentations, right? So or when you are making the reports, because you will be doing so many projects on the B school campus. You can't say that, fellow, what you wrote I didn't understand. Hey, we should be able to understand. I can't keep complaining that I don't understand what you guys are writing. So yeah, 10 notes means 10 numbers. Basically, all right, seat numbers. That's it. All right, there are 5 married couples invited to a party. At the entrance, each guest randomly draws 10 notes. You should understand what is written on the note. Seat number 1, seat number 2, seat number 3. You should understand. See, I am not forcing you to understand. This is the CAT question as it is. They are telling that you should be able to understand. What I can do about it, right? I also would have expected that probably you guys can word it little better to make it understand. So it's okay, but they felt that this should be able to understand. I am not saying you should be able to understand. They only meant that you should be able to understand. There are enough CAT questions like this. Okay, any which way, seat number 10. This is what is written on the note. If you want to understand that what might have been written on the note, this is what, no secret, nothing. These are the things what could be written on the note. So determine his or her place. That's what it is written. He's explained it. Draws 10 notes to determine why they are drawing these notes. Explanation is here to determine his or her place in a row of 10 seats. So naturally, by underlined statement, when you read the underlined statement, you understand that seat numbers would have been written on the note. What else could be written there? So because why? It is very clearly written. Why to pick those notes? To determine the notes you have to pick to determine where you should sit. Right, where you should sit. That is what is written on that particular note. It's not a currency note, my friend. Okay, are we all clear now? Yeah, okay. Now therefore calculate the probability that the man sits next to his wife. Very simple. So therefore what you are saying, A dash, that is one group, B dash is another group, second group, C dash is the third group, D dash, assume that these are the names of the couples, right? E dash, these are the 5 couples we are talking about. So the externally I have 5 groups, 1 2 3 4 5. So 5 groups externally can arrange in 5. I'm writing numerator, favorable cases. I'm writing my favorable cases for the event. So X, I'll let 5 factorial because A dash, B dash, 5 factorial. Now each group, I'll let know that is A dash can arrange in 2 factorial ways or 2 ways, or B dash can also arrange themselves. They can interchange the position. They can be left, right, they can interchange among themselves. Therefore, they can arrange themselves in another 2 ways, another 2 ways, D dash in 2 ways and E dash in 2 ways. This is my favorable case. But when they draw the notes, when they are picking those chits, denominator is 10 factorial ways. Total is 10 factorial because there are 10 chits. When you go and pick anything, first fellow can get any of the 10 numbers, second fellow remaining 9 numbers, remaining 8 numbers. Therefore, the denominator is going to be 10 factorial. Guys, is this clear to you? Is this clear to you? 5 factorial into 2 raised to power 5. If you want to write it, it can also be written like this, 2 raised to power 5 divided by 10 factorial. This is what is expected to be written after reading this question. Is this clear? Very simple. It is no big deal. Concept was known to us, right? Because when I asked this concept question, everybody answered it right. When I asked this concept question, everybody answered it right. But the point is, when we translated this into application, that is when we faltered, and that is what we need to develop. Concept was very clear because when I asked this question, almost everyone answered it right. There was no problem with that. Okay, good, very good, brilliant. So I need to simplify this. After simplifying, C is the closest answer. You get somewhere closer to 1 divided by 900 something. All right, 900 and something. So 1 divided by 9, all right, no, whatever. You simplify this, you will get this somewhere closer to 900 something. You can say that this is as good as 1 divided by 1000. So therefore, closest answer. Author only asked us to approximate it like this. Author only said that. Yeah, 1 divided by what? 945. Okay, yeah, 945. So closest approximation, definitely not 0.25 or 0.5 or this, none of this. It's very, very close to 0.0001. This exam, in the answer options were also printed like this only in the CAT question. Answers were also kind of printed like this. Yeah, that it may be. Yeah, sometimes the questions, that's right, Rishabh. Sometimes the questions may be printed like this, but coolly read it, you will be able to understand. 10 notes. Notes are there what? To determine. So here, continue. The notes are there to determine his or her place in a row of seat. Therefore, you know that the notes have been picked to put the seating position. Right, seating position. Srishti 1890 could be wrong, yeah. I think it should be somewhere in 900s. I remember these are CAT questions, right? I have done so many times. Somewhere closer to 1000 only, not 1800. That is too large, I guess, because that cannot be written as 0.001. That is not the approximation. Anyways, you correct it. That can be just an error with respect to calculation. No big deal about it. Yeah. Okay. Did you all learn something today? Did you all learn something today? All good? We'll continue this tomorrow night, same time. Tomorrow night, same time, we will come back and we will discuss this. So if you have liked what we are trying to do, so press the like, or now put the like button before you go there. If you liked it, if you didn't like it, don't worry about it. If you liked it, like it. And if any of your friends are also preparing, share it with them. Subscribe to the channel, subscribe whenever the lecture comes there, put it up so that you don't fail to attend it, right? It will be nice to see you guys also, right? As much as you like to see me, I also like to have you guys out here, except that all right, sometimes I feel that YouTube allows us to have the video interface, but sometimes it doesn't happen. Any which ways, yeah. So if anybody has the plus subscription here, I'm doing the IIFT lecture. I did about 2 lectures. You can join me day after tomorrow on that. Yes, the next lecture is we are doing on the YouTube. On the YouTube, we will do tomorrow night. We'll do tomorrow at 10 p.m. No 4 p.m. Tomorrow 10 p.m. We'll continue our study on PNC probability. We'll continue that study together because anyway these two things go hand in hand. We'll continue our study there. Keep reading, guys. So what I expect you is between today and tomorrow, spend some time yourself on PNC probability so that we'll be able to deal with the concepts a little better, right? So anyway, I'll give a background to the questions, no doubt. Wherever relevant background is required, I'll give this. But meanwhile, so if you may be doing some other stuff as well, devote some 2 hours or 3 hours, 2 or 3 hours, try and orient yourself, refresh yourself with PNC probability so that we can go little deeper and better as we go on to learn. Okay, here we come with the last announcement. So if you guys are looking at some free mocks, some of the free mocks, so you can also look at the 24th, this particular Sunday. 17th there was a free mock which is done, so you can also look at some other free mocks on upcoming Sundays. And anybody have some questions or would like to look for some brief interactions, you can be a part of this Telegram group, because some of you keep wondering how should I ask questions. This is one way. Not only there are many active participants out there. Definitely they will also help you wherein if it is required, my intervention is required, sure, I will chip in and I will try to respond to some of your questions. Yeah, that's pretty much about it. Good night. So any questions, let me know. Otherwise, we are fairly done. So I will see you guys tomorrow night. Yep. Good night. Stay blessed. Catch you guys tomorrow. Bye till then.